Hey there, welcome to a video discussing Unit 2, Lesson 3, which is on the normal distribution. So definitely you'll want to download these notes from Schoology. And if you actually do go to Schoology, here we go. Unit 2, obviously week 5, and you can locate the notes right here. So what's going on with the normal distribution? So let me put some bullet point items in this box here. So I'll get the annotate button, text, put a text here. So one thing is that it's a bell-shaped curve. Has area of 1 or 100%. Also, it's symmetric and unimodal, meaning there's only one mode. Remember, the mode is a number that shows up the most often, and you're not going to have bimodal. Bimodal will be like this. We have a distribution kind of like that, but here we only have just one peak. So that's what's going on there. Let me create another text box. Move it over. The mean, we tend to call mu, which actually, I don't know if I'm going to be able to type that here, but we call it looks like a U. Well, that's just great. Went away from the text box. We call it U or mu, just so you know. Standard deviation, we call it sigma, which kind of looks like a little O in a way with a little like symbol. Let me actually draw that in. So it kind of looks like that. Call it sigma, and that's mu with a little like line extending out from there. Or sometimes we draw it like that. So, and then lastly, sigma controls the spread. So again, we call it sigma, the standard deviation. So it controls how spread your data is. And you'll see, you'll understand in a second. Now, there is a little bit of calculus that's involved here. I'm not going to get into that. That's kind of beyond the scope of what we need to do in this class. But again, sigma controls the spread. So you kind of see over here, mu is right in the middle, or the mean is right in the middle. So you always put the mean in the middle. And you know, if sigma is really big, here sigma is big, so it's more spread out. Here sigma is small, it's not a spread out for that one. Now, one thing that's always going to be a guarantee is that 68% of data is within one standard deviation of the mean. 95% will be within 2 standard deviations. So all that, both in 2 standard deviations. And 99.7, so 99.7% of data will be within 3 standard deviations of the mean. So for example 1, we're given the mean and the standard deviation, and we're asked to calculate the percent of students who are expected to have particular scores, or to be within particular score ranges, or essentially the probability of something happening. And we can use normal distribution to figure that out. So for example, Mr. Han has 90 students. I got this from Mr. Han's AP stats class. So that's where I got these notes, in case you're curious. Has 90 students in his math class. The scores in the last test are normally distributed, have a mean of 75, a standard deviation of 10. So that's kind of a key phrase. You see the word normal. Of course, you're given the mean and the standard deviation. Remember, mean is mu, standard deviation is sigma. So you want to calculate how many students are expected to have a score between 65 and 85. Okay, so we have talked about z-scores. We're not going to really worry about that just now. So the mean is right here. That'll be 75. There is 65. There is 85. Right? and we want to be within one standard deviation. So the standard deviation is 10, so that kind of makes sense, right? This is one standard deviation, and that's another. Now, how can I actually calculate this? I know the answer is going to be 68.4%, because that's what we see up above. Or because we could just roughly say 68%, I suppose, but I know 68.4, if you want to be a little more exact. But how can I actually compute this using technology, right? So there's a few ways you can do it. You can use your TI-84 calculator, or you can use Excel, or you can use Google Spreadsheets. It's up to you. You use the TI-84 calculator, you can use Excel, or you can use the Google Spreadsheets. I think TI-84 calculator is probably going to be the best way to do this. But you can definitely do this using Excel or Google Spreadsheet. So let me show you each of those ways. Then I'm going to probably compute a few more of these and probably let you try some, maybe pause the video and see if you get the same answers as I do. But let's verify that this is going to be 68%. So here's what we do. If you go to your TI-84 calculator, let me pull it up. I actually have an emulator or something like that on my device here. So we'll go Smart View. It's just going to take a little while. There we go. It's just thinking. Okay. So you can see a calculator off to the left. Remember, you hit vars. Sorry, hit second vars. My bad. So you got to hit second vars and pick option 2. And then what you're going to do is you're going to type in the lower number in your range, 65, the upper number, which is 85, the mean, which is 75, and sigma, which is 10. Then you hit paste, enter, takes you to home screen, and then just hit enter again, and it gives you the answer. Actually, it's 68.3, so it's a little off. So again, just to walk you through it, hit second vars, that's a distribution feature. Select option 2, normal CDF, because the cumulative density, we talked about cumulative density in our last class. And punch in the lower and upper parts of your range, and there you go. Really simple. So going back to the notes, let's look at some other ones here. What if I want to be between 75 and, or so we'll do B, 55 and 95. So here's 75, right? 55. And 95. So you got within 2 standard deviations of the mean, right? So we just go back to our calculator again and change that to 55 and 95. And we expect it to say, oops, 55, 95, paste it, hit enter. So you get 95% roughly, 95.4. So that's really easy too. So there's a 95.4% chance your score would be between those two if the mean were 75, the standard deviation is 10, and if you assume a normal distribution. We usually have a lot of students, like 90 is a pretty high number. You can kind of expect normal distribution to pretty much happen. There are certain assumptions we have to make with normal distributions, which we'll talk about next week. Now, how can I do this in Excel or Google Spreadsheet? Well, in Excel, oh, here we go. So in Excel, if you hit equals and then norm, you can pick norm distribution, and it's going to ask for a few things. The X value, so unfortunately, you can't do it as a range between 65 and 85. So let's just do 85 first. That was the high end of our range. The mean was 75, standard deviation is 10. And we're just going to write true because we do want it as a cumulative distribution function, just like we did in the calculator. So you get that. So that represents what percentile 85 would be. It would be the 84th percentile, or 84% of data is to the left of 85, which makes sense because we've talked about that before. When you're 1 standard deviation above the mean, over here, and actually I can erase all this stuff. When you're 1 standard deviation above the mean, that's 68%, and this whole thing right here is another 16%. So 84% of data is to the left of a z-score of 1, or being 1 standard deviation above the mean. Obviously, this right here is 50%. If you focus on that, that's 50%. And that right there is 34%. So 50 plus 34 to get 84. If I draw that again, that'd be 50%. And this portion here is 34%. So hopefully that's easy. Now, if I go back to to Excel spreadsheet, I'm going to repeat that, but now I'm going to type in 65. So that so if you have a score of 65, 50% of data is still left is 65. Then I'm going to subtract these two from each other, A1 minus A2, because I want that difference, and you get 68%. And the reason I want to subtract, if you think about geometrically what's happening, so that's 75 and 85. So all this, we have this right here. Then if you do it again, 75, 65, that's all this. So this was that right there. That was that. So you want to subtract these areas to get the middle. So that's how you can visualize it geometrically. Oh, sorry, let's put 85 there. Okay, so hopefully we're okay with that. Now, if you want to go into Google Spreadsheets, you can as well. So new, we'll create a new spreadsheet. And I'm pretty sure if I hit normal, I'm going to find a feature for that. Equals norm dot distributes, I believe. I'm keeping my fingers crossed this works. 85, comma 75, no, comma 75, comma 10, comma true. Yeah, it worked. So it's the same exact thing you would do as you do in Excel. And that's free, right? We all have access to Google Spreadsheets. And then, of course, you do the next one, but put in 65, and then take the difference. So that's how we can approach some of these other problems here. I'm going to use a calculator instead, because that's just what I'll expect when we do have like live classes and stuff like that. And plus, you should not use a calculator. So you could do that same thing for C. You know, just punch in 75 and 85. I'll do it really quickly here. So second, distribute, option 2. So I'll go lower 75, upper is 85. And, gotta rewrite 75 and 85. Let's paste it. So you get 34%. So that's part C. Now, to be below 75, so here's 75. I know it's gonna be 50%, right? But how would you do this in the calculator? You go to, again, second, bars, option 2, and you're gonna put your lower as a negative large number, if that makes sense. We're gonna do -1e. E is a second comma, 99. So what that means is I'm doing -1 times 10 to the 99th power. So that's way far to the left. Like I'm doing like several orders of magnitude of z-scores to the left. So basically it's going to cover the far left tail here. And of course I'm going to make the upper 75. Hold on a sec. 75, and then paste, and it should say 50. There we go, 50. And it does that 0.05 at the end just because it is an approximation, of course. Yeah, so that's 50%. What about the other ones? Like here's 85, here's 95. So again, I could just use the graph calculator and just hit second bars, option 2, make that 85, 85, paste to get 84, do it again. And actually you could probably hit second enter if you like to repeat the previous entry and change that to a 95 right there, and you upper limit, and you get 97%. So 84% of data was less than 85, and for the mean of 75, standard deviation of 10, 97.7% of data is less than 95, with again, a mean of 75 and standard deviation of 10. And again, this should all make sense if we look back at the diagram here. So again, 84% roughly. Here's 97.7%. Let me look at one more time. I don't remember what the decimal was. 97.7%, that works for us. Again, if I kind of come back up here again, so remember the 2 standard deviation one, 95%. That means in the tails here, we have 2.5% here, 2.5% there. So of course, 95 plus 2.5 is 97.5. So hopefully we're cool with that. Let's do some true and false questions to wrap up the video. So since percent of students with scores of 75 to 85 is 34% of the students with scores, sorry, let me read that one more time. Since percent of students with scores of 75 to 85 is 34%, then of the students with scores of 75 to 80 must be half of that, 17%. So the answer is no, it's not. And the reason why is that our curve is not linear. So remember, if you were to draw this, here is 75, here is 85. Of course, 80 is right smack in the middle between 75 and 85, but those areas are different. Now, if I had a curve, well, not really a curve, but if I had like something that's more flat, if I had a distribution that was kind of like this, kind of like rectangular, and there's the middle and there's 85, then sure, I'd have the same areas, but you can't assume that. So be very, very careful there. Those will be different areas between 75 and 80 and 88 and 85. Let's look at some more here. And back in the day, people used to use like something called z-tables, which is a bit painful to do. So basically all that stuff the calculator was spitting out, all those proportions, you would get from a z-table. This is kind of the old school way of doing this stuff. And a lot of these were determined actually using calculus. But again, I'm not going to go into calculus because it's beyond the scope of this course. Let's go back to the PDF. So let's look at these remaining examples to wrap up the video. So here, find a proportion of observations that are less than 1.53 standard deviations above the mean. Okay, so this is a z-score 0 right here. And we could say that's roughly 1.53 standard deviations above the mean, and we want to be to the left of it. We want to be less than that. So how can I do this in the calculator? Now you could use, again, a table, and if I look at the table, the z-score table, which I do have in Schoology, so what you do is you locate 1.53, hold on, let me clear. So here's 1.5. 1.53 be like 1.50, 1.51, 1.52, probably like right there. So I'm expecting about 0.937 to be the answer. Now I can go to my calculator again. Now our standard deviation, because you're doing z-scores, you're going to make that 1 for the mean and 0 for the standard deviation. Sorry, I meant to say 0 for the mean and 1 for a standard deviation. That's going to be what is typical. So when you're dealing with a z-score, you always center your mean at 0 and standard deviation at 1. And we're going to punch in 1.53 here. 1 point, and I have to insert, in second, delete, insert, 5, 3. And again, keep this 1e negative 99 because you're going forever to the left. And you get 0.937. There you go. So again, when you're dealing with these problems here, where it's standardized, right? That's what it means, because you're kind of assuming kind of very standard conditions. You are going to set the mean equal to 0 and the standard deviation equal to 1. And that's what you do for the rest of these problems here. So for number 3, you can do the same thing, but now you're going greater. So in this case, if I go back to my calculator again, hit second, enter. Actually, let's just go this. Let's go this, option 2. I'm going to clear that. So I'm going to put 1.53. Now I'm going to put in 1e99. So 1 second 99. Go down here, 0, 1. Oh, I don't know why I did that. Let's try it one more time. Okay, let's try this again. Option 2. Okay. Let's paste that. Hit enter. So it's 0.063, which makes sense because it should be 100% minus 93.7%, right? Because you're going the opposite direction now. So remember, graphically, what's happening here is that we had all this to the left. Now here you have all this to the right. So if this was 93.7%, then naturally this would be 6.3%. If you're going exactly to the right of 1.53, whereas we went exactly to the left of 1.53 in the previous problem. So 4 or 5, you kind of do the same thing. And by the way, you can still do this in Excel. Just remember that when you do in Excel or Google Spreadsheets, it's always going to give you the area to the left when you hit whatever X is, the mean, standard deviation. So I totally could have done like 1.53 here, make that 0, make that 1, and you get that. So you'd be totally fine using Excel or Google Spreadsheets if you don't have a calculator with you. So 4 and 5 and 6, maybe you might want to pause the video and give those a try. So going to the left of negative 2.2 z-score. So, and sometimes we write like this, by the way. Sometimes we're in probability of z being less than or equal to negative 2.2. And we can calculate that. Here, obviously, we're in between the two, so you can write as a probability or just use p. Negative 9.1 less than or equal to z, because we're looking at z-scores, less than or equal to 1.37. For number 6 here, find force oscillations are 1.5 standard deviations from the mean. So, I mean, you're kind of doing the same thing. But again, we can use our TI-4 calculator or Google to Spreadsheets or Excel to do this. So if you do this in the calculator or other methods, you get 0.0139 here. So obviously, if you're less than 2.2 standard deviation, that's really low. So very low percentage there. Or you can write 1.39%. Don't care if you write a decimal percentage. It's fine with me. This one I think is 73.3%. And this one's going to be 86.64%. And you'll have some homework to practice this skill. Lastly, let's go backwards. So what if you have the percentile? So you have the percent that you're to the left of a certain value. So again, this is the middle. This is mu. And we want to be 21 percentile. So it means we want 21% of the curve to be to the left of this data point, which I don't know. So what z-score will give us that? Now, there's a way you can actually go about this in a reverse manner. Here's what you do. You go back to your calculator, hit second, bars. Now you're going to pick inverse norm, option 3. And I know the area is going to be 0.21, so you always put in the area to the left. And leave those alone because we don't know what the mean or standard deviation are, so we assume a standard kind of standard conditions here. And you're going to have negative 0.806. So z-score negative 0.806 will get us that percentile, 0.21. So again, that's negative 0.806, which actually should make sense because remember z-score is this, your data point minus mu over sigma, right? So if you have negative 0.806 and mean is 0, standard deviation is 1, so x of course is negative 0.806. Yeah, so that's how we get that percent. And plus, we could even look at the table, locate anything that's close to 21%, which is probably in this range over here, which is about negative 0.805 or so. Yeah, so that's what we got. Okay, and then we'll do this a couple more times. Oh, in Excel, you could do it like this. Equals, now norm, but now you do the inverse. So you have to give the probability, so 0.21 to the left, comma your mean, which will say 0, 1, and you get the same thing. And you can do the same thing in a Google spreadsheet, equals norm dot inverse. Didn't know why that didn't show up earlier. 0.21, comma 0, 1. Again, you get that. So you have lots of ways you can do this. So go and try 8 and 9. What z-score gives a 10th percentile, and what value z will give us a 6% of all officers greater than z. Now remember, if you're 6% greater than z, it means you're at 40 percentile. So you're going to use 0.4 as your input, and you're going to use 0.1 as your input. Okay, if you work this out, you should get negative 1.828155. That's that z-score, and the other one should be negative 0.253. So again, it's a little cut and dry with this stuff here. It's not terribly exciting, but we are going to look at some projects I've worked on next week, and I'll have you guys start doing the same. Some different data you guys can look at and start looking at certain data points in your data set and say, okay, what would be the percentile for this, or how many data points do I expect to be within one standard deviation, and see if that makes sense, and see if that is verified from your data set. You will find that when you have a lot of data, that we tend to follow a normal distribution pattern, and that this can be very good for predicting your results. And normal distribution, by the way, is absolutely essential if you're going to do linear regression. So if you're going to develop a linear function to predict outcomes, you have to assume normal behavior. Without it, your regression techniques will be worthless. So that's when we'll go down that path eventually this semester. Okay, that's the end of the video. Make sure you take care of the Google form and do the homework problems, and I'll see you in class on Tuesday.